where the heck is Adnan?
No idea.
Nobody's seen him at all. Could be in Galway as far as we know.
He's here.
Oh, we at least know he's in Dublin, huh?
Yes.
Okay. I just picked a random town. Okay. Last time we did Transformers, yes. And that was not so bad of a topic. I feel like I should do Kepler's laws now that Adnan's not here. That would really annoy him, wouldn't it? Will I, could I, maybe? No, I can't. No. Coulombs Law is what we're going to have a look at first. Okay, can you write that down? Hang on. Coulombs Law. Got that? Okay. Got that, Mayor?
Yes.
Yep. Yes, yeah. Yes. Okay. Yes. So, remember that a point charge produces an electric field. Let us examine the force between these charges. So, if you remember, we said, okay, if you have a charge, let's call it Q1, it produces an electric field. And I don't know if you remember, but the formula for the electric field strength at a point like here is 1 over 4 pi epsilon 0, or this constant K, times Q over D squared, the distance from here to the point. Now let's imagine there's a charge here, we call it Q2. So the force, or the E, another formula you have from it is F over Q, here. So you know as well that F equals EQ2, in this case Q2. So if we just use this formula, we can get this. 1 over 4 pi epsilon 0 Q1 Q2 over R squared. This actually is just Coulomb's law. It's the formula that gives us the force between two charges. So if this was a positive and this is a negative, then the force would be an attraction force, and if it was positive, positive, or negative, negative, would be a repulsion force. But basically this is the formula. So you can see that if you make one of the charges, or even both charges bigger, you get more force. If you put the charges closer together, more force, because this is smaller. Yeah. This formula here gives you the force, but it's the force on both. So in other words, if this one is being pulled towards 10Q with 10 newtons, then this one's being pulled towards Q1 also with 10 newtons. So, of course, because if you look at the formula, it doesn't matter if you swap these, because multiply, it's the same number. So this is Coulomb's law, which I think I probably have here. Yeah. So Coulomb's law states this. And K is a constant. Mir, get off the phone and write this down. Tamam? Tamam. You wrote this down here, Jeff? Okay. Yeah. Okay. Continue. Yeah. Okay. So this is Coulombs Law. All right. So here's an example of Coulombs Law in action. This is an electron. This is a proton. They're opposite charges, so there's an attraction between them. So the force, there's a force here pulling the electron to the proton, and you can calculate this force by using Coulombs Law. So let me just draw that here. Proton, electron, and there's a force here, and it travels around in a circle. But here's the strange part. I said a moment ago, there's also a force this direction, which is equal to F. Because we just said a moment ago it's the same.
Mm-hmm.
So my question now is, well, if the forces are the same, why is the electron the one that's moving and not the proton? Why is it this way around and not the other way? Why doesn't the proton orbit the electron? Or why don't both of them move?
Because of the charge?
No, well, they both have the same charge.
Because of the mass?
Because of the mass, yeah. Because you've got to remember as well, F equals ma, A equals F over m. So although the F is the same for both, the m is definitely not. Which has the smaller m? So which has the bigger A? The electron, because of the smaller m. So although the F's are the same, the accelerations are definitely not. In fact, this acceleration is nearly zero. The mass of the proton is so big compared to the force that this is nearly zero, and therefore no acceleration means no movement. Whereas this acceleration is definitely not zero, it's quite large, because the mass of the electron is so small. And this is the reason why it's the electron around the proton. Even though it's the same force, it's the electron that orbits because it's smaller. And we've just explained. So there's nothing for you to write here, I just want you to appreciate why it's this way around and not some other way around. So often for these problems we ignore the proton. So although there is a force here, because of this being so small, often in our pictures I won't even bother to draw the F in. Do you know what I mean? I'll just draw my picture like this. But I just want you to understand that there still is a force here. Okay. Right, now, when a charge Q, small, is trapped in a circular orbit by another charge, big Q, it will have potential energy. Will the potential energy be positive, negative, or zero? Negative, yeah. So, just like in the example I drew here, this electron has negative potential energy because it's trapped. It would need energy to be freed. You know the name of this energy from chemistry. What's it called? Think hard.
Ionization.
Ionization energy, the energy to free an electron. That is exactly what I'm saying here. It's trapped, it has a negative potential. The amount of energy required is what's called the ionization energy in chemistry. But we have a way to calculate what this energy is, this negative potential. It has negative potential, and the formula for the potential energy is this here. Now you notice that it looks a lot like Coulomb except for two big differences. What's the two big differences? It's not an R squared, and a huge second difference
Is the minus?
The minus, it's trapped, so its potential energy must be a negative, so I put the minus in here. The only reason I did a small q and a big Q is to kind of just, I didn't want to say Q1 and Q2, I could have. Usually in my pictures, if I do have two things like this, I'll call this one Q big and this one Q small, because it's like at the center, it's the big thing, and the other one is the small thing going around. Yeah. Now, I suppose technically I don't need the minus here, because if one of these is positive and the other one is negative, when they multiply the result is negative, but I guess I'm trying to stress that this should be a negative. Yeah. Anyways, let's continue. So Coulombs law gives the size of force between two charges. This force, the force between charges, is one of the four basic forces of nature, what we call the fundamental forces of nature, and there are four of them. And Coulombs law is also an example of what's called an inverse square law in physics, and these are surprisingly common in physics. An inverse square law is one that has a square in the bottom. So Coulombs law was K Q1 Q2 over R squared. This is called an inverse square law. And they're really common in physics. Why? Well, I want to give you don't have to write this part down. It's not on the exam, but I just want to give you a reason why when you study physics, so often you'll see an R squared in the denominator. What's happening here? So you could pick any physics problem whatsoever. So imagine you want to try and figure out a formula for how bad someone smells, even something silly like this. So you have their stink coming off here. We'll measure it in some units, I don't know, 100 stink units perhaps, whatever, yeah. Now, what? So maybe we should say something like mere units, is it? Yeah. Anyways, whatever it is, this spreads out. Does it get bigger or smaller as it spreads out? Please concentrate. Does it get bigger or smaller as it spreads out? Smaller. And the reason is, let's imagine per second there's 1 unit of stink coming off here, and this area here is 1 meter squared. So it's one unit of stink per meter squared. When it gets out here, it's spread out more, hasn't it? So maybe this is 2 meters squared. It's the same amount, but over a bigger area, so it should be half then. And then here, let's say this is 3 meters squared, it's less per area. Do you understand what's happening? So, we need a formula to calculate the area here, and the formula for the area of a ball is 4 pi r squared. So when the person is standing here, how much they smell will be the smell at the beginning divided by the area, because it's spread over a bigger area. So this is the reason why formulas often have an r squared in the denominator. It's because the force, the charge, the whatever is getting spread out over a bigger ball as it moves out. And this is the thinking behind these formulas as well. So like, as the charge spreads out, it gets weaker, you know, so it's being spread over a bigger area. So we had a look at an example of why. And the other thing is, I do want you to note in the formula, the K was very, very large in the formula. I think it was something like 8.99 times 10 to the 9. That's really, really big constant. Okay, so here's one to get started. What is the force between a proton and an electron when they're 0.1 nanometers apart? I think using the Coulombs formula you should be able to calculate this. Your calculator has the charge built in, and you don't need to know the mass, just the charge, which is constant number 23.
The charge? Yes.
Yeah. Okay.
What is the R?
The R is 0.1 nanometers.
10 to 9.
For the force, 2.3 10 to the minus 8. Yeah, okay. Let me calculate it now. Mir, do you have it yet?
Okay. No, that's not the case.
Did you use small k?
It's Kelvin, like the constant. No.
You don't have the K in it.
No, you don't. You have to type it in. Okay.
Yeah.
8.99 times 10 to the power of 9 times, and then on the top it's Q1. Oh, what happened? On the top it's Q1 multiply Q2, but they're both the same because, yeah, so it's just a square. And the distance is a square, and it's 0.1 nanometers, which is to the minus 9. So it comes out at 2.3 times 10 to the minus 8. Let me put that in nanos. 23 nanometers is what I got. 23 nanometers. Sorry, thank you. Nanonewtons, thank you. Okay. That was okay, wasn't it? Just using Coulomb's formula. So here's another one for you to try, which I'll do. Not as quick. How long does it take an electron to orbit a proton, which is orbiting in a circle of radius 0.20 nanometers? So the orbit is 0.20 nanometers in radius. What is the time for one orbit? So we're back to circular motion.
Okay.
Kind of the UV.
Why not? UVATS is only for linear motion, not circular. Big difference.
2 pi.
I need F.
F would be a good start, yeah.
And then the A.
And then the A, and then yes, dun, falls into place. So the first thing you can easily calculate is the F, because you have the charges. Just like in the last example. And you have the masses.
Yeah,
Do you have the masses? Yeah, you know mass of proton and electron. So if you have the force and the mass, you also have the A, the acceleration. If you have the acceleration, then you can get the omegas and the times and so on.
Okay.
Omega and then the time.
Yeah.
So I got the force.
What is it?
5.76 by 10 to the power minus 9. Like this with 2.2.
Okay. Yeah.
Yeah.
And divide that by the mass of the electron. Over 6, 7, and all of it. Yeah. That's the A equals V square over R.
Yep, that's one. And then V is also equal to omega or. It's really the omega that you want because T is 2 pi over omega.
And omega equals 2 pi over T.
Yeah. But you're better off saying V equals, see, you could get the V. If you want, you could say A equals V squared over R. Do you know the R? Yeah.
R and the A.
Yes, you can get the V. And then V equals omega R. So you could get the omega. And then T equals 2 pi over omega. So you know.
Okay. Let me write this. A equals
6.33 by 10 to the power 21.
What is the F mean?
Hmm?
What is
V squared over R. Okay.
M?
F?
No, we have, after that we have found the,
No, before the A. What is the
how much was it? 5.6?
You have a calculator.
5.6 something.
10 to the minus 8, I think you said.
Minus 9. 5.607.
Minus 9.
and the A?
6.33 by 10 to the power 21.
21?
No.
Minus one, you mean?
No, not minus, no.
No, the acceleration I think is pretty big.
Yeah.
6.33 times strength to the times 0.3 times 10 to the minus 9.
Then what is the V?
Whoa, wow,
Yeah, now.
Miss Sharif, don't you have a
Oh
calculator?
my god.
Oh my god.
This is the V square.
Oh my god.
Square root answer is huge. Still.
It's much less than
Should it be?
I think electrons orbit protons extremely fast.
This is like really huge.
So,
I'm supposed to
one
multiply
one two
R by
five one
A.
six six.
V squared equals AR. So V equals square root of AR.
No.
V squared equals AR?
Yeah. A equals V square.
Oh yeah, you cross multiply V squared equals AR, yeah. And you got the A, you multiplied by the OR, that's the V squared, and square rooted, and it's still pretty big because the A is so big.
Yeah.
1125166.
1,
Is that okay?
1
yep,
2 5
yep,
1 6 6 7
it's okay.
5 6 5
Because you, V over OR equals omega. Yeah?
Yeah.
So now we divide it.
By R.
0.6.
Times 20 minus 9. Omega equals 5.
6 2 5 power
minus
2.
2.
Okay, so now
Wait, radians per second?
For the omega, yeah.
now we find the 2 pi over t and then we'll come down
2 pi over omega.
So T equals 2 pi over
This is the minus one second. For the
No!
We can do it.
It's gonna change, go back. The answer is different. Go up. Okay.
Did Mir screw it up?
Yeah.
Okay.
No, okay, I'm just gonna do it.
6.5, no, it's fine, it's right.
Yes, okay,
Yeah,
okay.
so now we'll do
2 pi over answer.
one point 765 to the power 16.
That's
That's the time. What'd you get? 1 point.
76
Yep.
to the power 16.
No, you know that's wrong, because you're saying it would take that many seconds for the electron to orbit the proton.
yeah, okay.
It's way too big. The time should be small. Time should be tiny. The electron should be zipping around the proton super fast.
Can you do it?
Yeah, we'll do it now. So, let's see, where's my pen? So you know T equals 2 pi over omega, and you have omega equals V over R. Yeah. But maybe we'll start with the F like what you did. So you have F equals ma, and you know the F from Coulomb, it's 1 over 4 pi epsilon 0, or what we call the K. So you know what, did you use, you okay, so I'll say K Q1 Q2 over R squared equals m E A. Since it's the mass of electron. Now the Q's are both the same, it's a proton and an electron, so that would be K E squared over R squared equals m E A. So if I just divide here, I get A equals that constant K E squared over mass of electron or squared. But you know from circular motion A is V squared over R, so we could cancel that with that, and we get V is square root KE squared over ME, which is E root K over ME, because I just put the root in. Now, we know that T is 2 pi over omega, and I think we said omega is V over R, isn't it?
Yeah.
V over R is omega. Yeah. So that means T is 2 pi R over V. And we have the V here. So the T is 2 pi R over V, over this. So over E with the root. And because the root's a fraction, it just gets flipped upside down. So I just did it this way so that I wouldn't have to type things into the calculator more than once. So I just want to type things in once. So we have fraction and we have a root. So on the top is 2 pi, and the R is 0.2 nano. And then on the bottom is an E, which is 23 on the calculator.
The mass?
No, the charge, E. Yeah. And then inside this fraction is the mass over that K. Yeah, 8.99 times 10 to the 9. And then on the top is constant 3. So this is the type I was expecting, a very small time. If I put this in pico, I get 78, so 79 picoseconds. Yeah. So this is the right answer here. I wouldn't necessarily recommend doing it this way in the exam. The way you were doing it was just fine. It's just the problem you had was you weren't writing down all the numbers you were getting on the calculator. Then as soon as you made a calculator mistake, you lost the numbers that you had previously. Okay? Yeah. Right, here's a simpler one. What's the potential energy of an electron orbiting a proton at this distance? So this is just a straightforward type it into the formula I gave you. So tell me what you get here.
No, this is good.
How many boys are there are?
I don't know. That's him.
Why is that?
It's him. No.
My kids doesn't have that kind.
So buy one of these.
23.
Don't be so cheap.
Let's see what.
20%.
Alright.
Oh, yeah.
Minus 1.5 times 10 to the minus 18.
Let's have a look.
Joules.
Joules, yeah. So the formula was 8.99 times 10 to the 9.
Yeah. No problem.
This is what you got?
Yes, yes.
Yeah. He needs calculator support.
Yeah.
It's more than just calculator support he needs. Right. Do you get this one? You got this one. 1.54 times 10 to the minus 18 joules.
What is this in?
Let's
Pico.
Pico is 12. 15 is femto. 18 is septo. 1.54 septojoules? I don't know. You ever found out, do a quick Google, prefix 10 to the minus 18, is it, I think it goes pico, femto, septo?
What should I search for? 18?
10 to the minus 18 prefix. I don't remember this one from the ESCP lesson.
Me neither. I still have the paper from it.
Yeah.
Minus 18 is Eto.
Eto. With an I or an E?
Double T O.
Say again?
Double T O. Eto.
Proper.
10 minus 18 is A. Symbol is before it.
A.
Femto. Femto is
Otto.
minus 15.
Ottojoules. What's femto?
It's
15?
minus
Yeah.
15,
But after femto I thought it was seppo, but it's
Yeah.
otto. When's seppo? After otto?
After Otto it's Zepto, yeah?
Yes, okay, so I forgot about otto. 1.54 ottojoules. Got that? Okay. Now. Okay. 211.
5 days. Ever.
Yeah, okay. So we'll do these now together, okay? As you can see, some of them are very easy, like you just use the formula and you're finished, and some of them you have to do some calculation with circular motion.
First two we will do, second two
We will.
I got a better idea, yeah. First four you will do, and then first four I'll do after you do them. Let me just have a look here. 1 is okay, 2 is okay, 3 is okay as well.
And number 4 there is no information given.
In which one?
No number. It's one number.
And
Yeah.
there's no use like one time only.
I think you'd be okay with 4.
No, because if you say that an electron is a number.
Yeah,
Proton.
yeah, this is a number. Yeah, yeah. Okay, try these now, and then when you're finished them, I'll do them. So get working on these now.
From 4 protons.
Multiplied by 4.
Really?
Mm-hmm.
You know for one what counter here. And we will be able to take the whole classes.
Do you have to go to EAP support?
Calculator. No.
Oh.
It's a good idea for a class. Really.
For people like me, it would be helpful. You don't need that one because I'm not looking for the time. Yeah. Yeah. No, but you don't need to find the omega for 2. If you find the acceleration, then you practically have the answer. Yes.
Really best to be able to find out.
You got it, I think.
You do not. What do you say?
You have to,
Oh,
you
I
calculate?
multiplied by 2 first.
You did the 2, okay, good, yeah.
I just did.
Yeah, it's an electron orbited 2 protons.
so after it's multiplied by 2.
Did you multiply by 2? I will multiply by 2 now.
And electron is 1.
This, or this, and then multiply by 2. Don't put the 2 inside. Please forget it. You probably do that.
You just multiply the answer by 2.
And just multiply by 2.
Now you remove all this and then
This, okay, this. Yeah, this. So, I have, y dash y 6, 7, 0, 8. This is A. Square root answer times 10 to the minus 10. It will be 22.
22.
An electron is trapped.
Electron volts, so just don't worry about that until the very end. Once you get your answers in joules, convert it into electron volts.
When you multiply by the, you extend get the answer.
Yeah.
Joule, and you multiply by the electron charge, so you get the EV.
Oh, okay, yeah. I can read that.
Yeah, you forgot it, sure. Alright, I'll be back in just a minute with a cup of coffee. When I come back, you should be finished these 4. I'll give you a little hint for number 4 before I go. In number 4, what's happening is a proton is fired at by an electron. So imagine there's a proton here, and the electron is, the proton and a proton. A proton is fired at another proton. So as this proton comes in, what's the force between them? Attraction or repulsion. So what will happen to it as it moves? It'll slow down, until it stops, and it gets pushed away. So I tell you that the closest it gets is 1 nanometer. So it comes in, slows down, stops, and then is pushed away. The way to find the V that it was fired at is you need to be looking at the energies. So there's a kinetic and a potential at the start, a kinetic and a potential at the end, but you realise at the end when it's stopped, then the kinetic is 0. So in this way, you can get it. And another final hint is, I don't tell you where I fire it at, which in physics means it's fired from a great distance away for the problem. So you can take the distance at the beginning to be nearly infinity. That it's fired at a great distance at the proton. Now, of course, it's not fired at a great distance. It's probably only fired like 2 meters away. But 2 meters compared to the size of a proton is practically infinite. Okay, you got the idea? Good. Okay, so hopefully when I come back, all 4 should be finished. Hopefully. Yeah. Now you can relax as long as you're still working.
Yeah. For sure.
Oh, good.
I feel like I'm on the beach.
Where the beach?
How much energy is required? You may assume the speed, and therefore the kinetic energy remains. V equals minus K. 8.99.
I see the thing in your eyes.
شغلت مشكلة ومحيوك العالم
6723 squared over 10 to the minus.
Do you have black pen?
No.
Do you have black pen? Okay.
Is it flat? I think this is flat.
Right. What am I doing? What is the formula for P? Just, oh, no R squared. No, it's not squared. 2.3 minus 23. What? هل يجب
لا طبعا أنا وصلت ذلك
So do you have black? Is it black? Also? Look, Steve said to me, you have to bring the receipts for the medicine. My manager to call the receipts. Yeah. Now, Steve asked me to bring the receipts for the medicine.
Yeah.
I asked my manager, she took it. Like, someone else bought the medicine and she took out the receipts for me. Not there. No, did you do the answer? Yeah.
I did 3 now, I don't know what to do for.
Then that's enough.
Any proton is fired at B towards B, 3 protons. As they said, electron acceleration approaches the proton with very close to force. What is the value of B? طيب ها قال KE plus PE equals KE plus PE or kinetic force.
أجل اختبار infinity
هم infinity على بالك؟
Man, why don't you come to the club? Let's come to the club. It's me, you, and yeah. Well, I swear, I want to see the way you do stuff. I swear, you know, you not so hard if you get so hard. Because you up to you, no? Up to you. Yeah, that was fun.
This is all recorded.
Really?
Really?
Then why you play this song?
Yeah, why
I
did you
know.
play this song?
I'm sorry, yeah, I'm sorry.
Yeah, do the answer. Mr. C will come and he will fight with us.
Sorry.
Did you read the second one? Give me the answer for the second one.
I think it's just this.
What?
So we use the potential energy equals minus K Q over R.
And what about the four digit back?
I don't know what to do now.
Let me see. I said, you said that if you are relaxing, do the homework. I will tell you your pretty much.
Nearly finished?
Nearly finished.
Give it another minute. So, I think there's a chance you might get it. Again, you're looking at the kinetic and potential at the start compared to at the end.
Which potential energy formula should I use?
The one we have from today.
Today.
What is the R?
Told you already.
1?
No.
J.
Yeah. At the beginning.
Yeah.
At the end, it's given.
1. 9.
So it's possible. Give me please.
No, 1.
Oh, it is probably that I need to say.
Yeah. Okay, did it?
Did you?
This formula PE equals R and this K Q P A K R is 1 and mass of the electron of the proton and this
Potential energy equals kinetic energy.
Yeah. No, but he said that let's put the
Potential and you said potential and kinetic energy at the start, so it's K E plus B.
Yeah, but the PE is 0 at the start. Make sure it's right.
Okay.
And at the end, what's 0?
Kinetic energy, so it's this. Okay.
See, I thought you'd get it.
So this is gone and this is gone. This is this.
always the kinetic energy equals
The
Yeah, I
classic.
know.
next year.
Oh no, it's still, yeah. It's a common thing to use, common trick. It's a proton fired at 3 protons.
So if P in, then multiplied by 3.
Yes. Yes.
But V has negative, so if I want to get rid of that, if I don't get the V at the end, I have to take the square root to the negative.
Yeah, get rid of the minus. The minus. Well, actually, no. You see, it has a plus potential energy because it's protons and protons, not proton and electron. It's not trapped because they're both protons. It never has negative potential because it can never be trapped. It's always repelled away. The V, I think the V should be pretty big. Probably because the protons want to repel each other and they get pretty close, a nanometer, you'd probably have to fire the electron quite hard.
Okay, I tried everything.
Okay, good. Let's have a look. So the first one, I think I can just have my calculator open. It's 2 electrons and 4 protons. What's the force? Okay, so the formula is 8.99 times 10 to the power of 9 times fraction. And the distance, what was the distance? 0.09 nano. And that's, of course, squared. Thank you. Minus 9. And then on the top, what is it? 2 protons, 2 electrons, and 4 protons. Did you get this?
No. We multiply by 2.
Yeah.
Did you? Yeah, because your brain was set to looking for numbers and not. Yes. So take care in the exam with that, okay? So that is 228 nano newtons. 228 nanonewtons is what you should have for the first one. Okay. Number 2, I can't quite write this one down. An electron orbits 2 protons. What is the velocity? Okay, so we have electron orbits 2 protons. So the V is equal to, well, we have A equals V squared over R. So V is equal to square root AR. But from Newton's second law, what's A? It's F over R. And we know how to get the F from Coulombs Law. It's K Q1 Q2 over R squared. Now Q1 is an electron and Q2 is 2 protons. So that's an electron and 2 protons. So that can cancel that, and this makes an e squared, which cancels with the root. So the simplest I can make it before I use my calculator will be e root 2k over rm. Now, of course, I didn't expect you to do it this way, because I want to just type it in once on the calculator. So we'll see if we get the same answer. Square root fraction 2 times 8.99 times 10 to the power of 9 over, what was the or? 10 to the minus 10. And then the mass is number 3 on the calculator, is it? What answer did you get, by the way? 22.5 meters per second? Okay. Seems like, now hang on, this could be my mistake. I don't think...
It's really the same numbers, but different...
You got something went wrong with a power. Is it like the mistake I made earlier where you forgot the minus on... Or you maybe put in a minus and where you shouldn't have on the 10 to the 9? But you got same numbers, but your decimal point is off.
Yeah,
1, 2, 3.
Yeah, it's 22.5.
6 times off?
Yeah.
6 times off means because there's a square root in it as well. Your answer 12 times off. Not. I have a feeling it's with your 10 to the minus 10. I'm willing to bet that maybe somewhere in your type-in you typed in 1010 instead of 10 minus 10. That would be my best guess of what went wrong.
No, minus 10. I don't know.
Yeah, I don't see any mistake here. Did you find yours on the calculator? No? We can't both have different answers. Let me have a look. Show me what you did first.
This is as far as I can go back.
Yeah, what was this step?
This was the force, and then I multiplied by 3 plus 2 electrons.
Fair enough.
Multiplied that by mass.
Yeah, so this is your acceleration.
Divided by the mass, get the A. This is the A.
Yeah.
Times R and square root. Get the B.
Let me type it in. So it's possible that the first thing maybe went wrong. So what was the first thing you found? And I'll find it too. The force, was it?
Force.
Okay, let's calculate that. Can you check what did you get for force?
I can't.
Didn't you have the number up on the screen?
That was times 2.
Okay, well then I'll just do times 2. Well, but that's the final answer for force.
Yes.
Yeah, so I'll calculate that.
Okay.
So it's K Q1 Q2 over R squared. Oops. So the R squared, and then on the top is 1 electron and 2 protons, yeah? So I'm putting the 2 in now. Oops, sorry, what is the problem? I think it wants me to put a multiply in. Now, what did you get for the force?
Yeah, it's squared. R squared. That was
You forgot the square on the or. So it wasn't 10 to the 10 that was the problem. It's just you missed the 10 to the 10 because you didn't square it. Yeah. Okay, so that's fine. That's fixed now. Number 3. Yeah. Okay. So number 3. An electron is trapped in orbit around a proton. How much energy do you need to free it? Okay. So that's equal to the potential energy, which is a negative, and it's electron, proton, and what was the distance? 10 to the minus 10 again? Yeah. So it's just actually this in electron volts. Oh no, it is not. Thank you. Okay, so I'll just get rid of the square here. Get rid of the 2. Yes. Did you get this? And then we have to convert that into electron volts, which we can do by dividing by the E constant. Great. 14.4 minus 14.4 electron volts. Yeah, that's what you got? Yeah, great. Okay, and 4 now. We have 3 protons and a proton that's fired at it. These kind of move away, but because they're bigger, they don't move that much away. So this here has only kinetic energy because the potential energy we consider it to be roughly 0 since it's so far away, the ore is so big. Here this has kinetic energy and potential energy when it gets to here, but when it gets to here it stops and then turns around, so the kinetic energy is 0. So we can say the potential energy here equals the kinetic energy here. So we can say K Q1 Q2 over R equals a half m v squared, and we're looking for the v, aren't we? So we can say v is square root 2k q1 q2 over r m. M comes down, 2 goes up in square root. Now actually some of this stuff we know, these is 3 protons and an electron, so it will be 2 times 8.99 times 10 to the 9 times E times 3E all over, what did I say the distance was? A nanometer, which is 10 to the minus 9 times the mass of the electron. So let's see what we get here. Oh, sorry. I forgot what we were doing. Protons, not electrons. That's constant 1, isn't it? 2 times 8.99 times 10 to the power of 9 times E times 3 E over 10 power minus 9 times constant number 1. You got a big number too? Yeah. 28.7 kilometers per second. Okay. Right. Ms. Cherie, did you get any of these right?
Yes, all of it.
No. I didn't calculate just over.
Are you going to buy a good calculator?
The year is finished now.
You will need afterwards also.
You need it in the exam.
Like even
You'll need it in the exam and at university.
This will be 6 years.
Yeah, it's a good investment.
6 years.
Only?
No, he said he has it for 6 years. How much was it? 20 euros?
6 euros. 6 years. I had it for 6 years. It's 25 euros.
I buy this for 18 euros. I will.
Think about it, that's like 2 or 3 euros a year. It's a good investment.
Why then? Well, it's very good. Same one.
Like it depends on the time, right? On the time.
Are you going to buy one? For the exam?
I'll buy you one as a gift.
Yeah, when's your birthday? Yeah.
When's your birthday?
No, in January.
Okay. What?
You never
You
told
didn't
me.
say anything, man.
I told you.
No, you didn't.
You didn't tell me.
Yeah.
Then it's new one.
Okay, yeah. Happy belated birthday.
You can get a new Casio 991.
Yes.
How old are you?
Perfect.
Yes.
Yeah?
Estimate.
23.
Huh?
23.
No.
What?
21.
What?
Here's another one.
Should I increase or decrease?
Of course, it is.
20. Do 20.
No.
22.
You are right.
Okay.
You became 21 after that.
Yeah.
Wow.
Well, how about yes?
Yeah.
Yeah.
18.
20.
Yes, then.
22.
Okay. 40.
Today you are having a good lunch.
It's just chips.
Oh yeah, happy birthday.
I go there sometimes. I like it. I like it. It's just simple. Chips, pizza, cake, whatever. Nothing fancy. I tried asking for soup. No soup. Soup is too fancy. You go there often? Yeah?
Yeah.
Almost 3 days.
When? Yeah, yeah.
Oh, he's Algerian, is he?
Yeah.
Yeah.
Nice, yeah.
Yeah.
Do you know him?
Yeah.
You know him? Yeah. Well, a little bit, yeah. Yeah. Yeah, he seems like a nice guy. But he doesn't seem too busy.
Like it's good, his business is good.
No,
It depends on the
we
time.
meet in the breakfast time at the lunchtime.
It depends on the time.
Yeah.
Breakfast time?
Yeah. Lunchtime.
Are customers getting breakfast or what? What?
When we say breakfast, we mean the 1 o'clock one. In Arab culture.
Yeah, in Irish culture
The
that's
lunch is
lunchtime.
5, the dinner is 9 or 10.
I don't do breakfast.
Let's continue. Still have a little bit left, I'm afraid.
Why we should
New lesson? New lesson.
Let me think. Well, I don't know. Our choice.